Okay, so I wanted to discuss an interesting problem that uses Bayesian probabilistic reasoning. And when I say interesting, it's because it's very abstract and comes from the world of philosophy. And specifically, this comes from a man named Phillip Goff, who is a philosopher of mind, which means that he spends a lot of his time thinking about consciousness and the mysteries surrounding consciousness. But this particular thought experiment isn't directly about consciousness. It's about what's called the fine-tuning problem. And I'll get into that in due course. But specifically, Phillip Goff, in his thought experiment, invokes what he calls the reverse gambler's fallacy. So I want to talk about the fine-tuning problem and the reverse gambler's fallacy. And then also point out where I think that Phillip Goff is not reasoning correctly. And I could be wrong about this, but I think it's interesting nonetheless. It's an interesting case study in probabilistic reasoning. So let's start by defining what the fine-tuning problem is. So roughly, it says something along these lines. Our universe, including ourselves, are dependent on the laws of nature, and that these laws of nature depend on the values of certain parameters, for example, the gravitational constant. Okay? And had these parameters been different, we and everything we know would not exist. At least would not exist as we know it, may not exist at all. There may be no possibility of a universe where, say, the gravitational constant was a little higher or a little lower. I'm not a physicist, so so forgive me if I'm getting the details of this not exactly right. But in other words, it seems that when we look at the universe and we look at all of these parameter values, it seems that these parameters have been fine-tuned to allow for the universe as we know it, including us, including our lives and our consciousness, etc. And this is a curious thing. And so what better accounts for this apparent fine-tuning? Is it luck, or is it something like a god, something with intention that intended to make us or something like us? So that's roughly what the fine-tuning problem is. Okay. Like I said, Goff is going to use what he calls the reverse gambler's fallacy. But so to understand that, you might want to know what the gambler's fallacy is. The two, even though it's called the reverse gambler's fallacy, you can see why it's called the reverse gambler's fallacy. But don't try to do too much mental gymnastics when you learn what the gambler's fallacy is, trying to figure out what the reverse gambler's fallacy is. I'll just state both. And the conversion is, at least for me, not super intuitive. But nonetheless, the gambler's fallacy goes like this. So assume a sequence of independent events. And so this might be a set of football games, or what we'll use here, coin flips, a set of a series of coin flips. And we're going to take each coin flip to be independent of the other. And just to make this particular thought experiment a little bit easier, assume that the coin is fair. It's just as likely to land on heads as it is on tails. Okay, so say that you observe in flipping this coin many times, you see a heads, and a heads, and a heads. What is going to come next? Okay. So one way of reasoning you might reason that okay, well, I've seen three heads, so possibly the coin has a bias or something like that. But at the beginning, I said, let's just assume a fair coin. But nonetheless, if you didn't assume a fair coin, you could assume that what's next is heads, and it's because that there is evidence of a bias. Okay, and that would be fine. That would be completely legitimate, valid reasoning. But you might instead say, I think it's heads. And you might say, because there's some kind of momentum. It did heads, heads, heads. And so I think that the coin is picking up some kind of momentum, or you might call it something like that, okay? Or you might say, well, it's tails. And you say, look, it's had three heads in a row. It's due for a tails, okay? And these latter two, these are examples of the gambler's fallacy. In other words, what they are doing is they're saying these past events, these are somehow affecting future events. Okay, and so again, if we're assuming independent events like a coin flip, or like a football game where it's two teams playing the first game and then a separate two teams playing the second game and so on and so forth, we shouldn't assume that the first set of events has something to do with the next set of events, okay? And when we do believe that, then that is a gambler's fallacy. Okay, so what is the reverse gambler's fallacy? So again, assume a sequence of independent events, and this time for the thought experiment, we'll use a roulette wheel. Okay? And instead of announcing whether it's red or black or that's the data that we collect, what we're going to collect is correct bets versus incorrect bets. Okay, so you're watching somebody in the casino or something like that is placing bets, and you have a track record of their bets. Okay, and so you observe that they get the first bet correct and the second bet correct and the third, and so on and so on. And in fact, you observe that as long as you watch, let's say, 1 trillion roulette wheel rolls or whatever you call them, that this person bets correctly every single one of those times, every single time, 1 trillion times in a row. Okay? And so then you're asked, or maybe you want to conclude from this or make a guess as to how many people are playing roulette. Now that question probably seems to come out of nowhere, but in the next slide I'll explain where that comes from and why it's relevant to the fine-tuning problem. But let's just take it from here, okay? So you might conclude that because 1 trillion correct bets in a row is really improbable, that many people are playing roulette. In other words, you would have to go a very long time before you got 1 trillion bets in a row correctly, right? And this is what the reverse gambler's fallacy is. It's saying that an improbable result is the outcome of many trials. That's the reverse gambler's fallacy. Okay, so let's apply this then to the fine-tuning problem. Okay, so we'll set it up very similarly. So assume a set of independent parameters. Okay, remember that the fine-tuning problem relies on or is trying to explain why all of these different parameters are set to what they are. And so again, so each one of these parameters, they're either going to be compatible with the universe as we know it, or incompatible, C or I. And so we look at the first parameter and it's compatible, and we look at the second and it's compatible, and we look at the third. In fact, every single one that we look at, out to however many parameters there are, I don't know, but a physicist would probably be able to give you an estimate, that they're all compatible with the universe as we know it. In fact, that is the situation that we find ourselves in, right? Because we are in the universe as we know it, almost by definition. And so all of the parameter values that we see are consistent then with the universe as we know it. It's just almost circular. Okay? And so then, just as we asked how many players are playing roulette, here we ask how many universes are there. And we might conclude that all parameter values being compatible with the universe as we know it is improbable, and therefore we conclude that there are many universes. Okay, and what the reverse gambler's fallacy says is no, this is not good reasoning, because again it's saying that an improbable universe is the result of many universes. Okay, and so that is a fallacy in reasoning. Okay. So now why would this question be relevant to the fine-tuning problem? Well, because if there's many universes, or if we have evidence that there's many universes, then luck becomes a more probable solution to the fine-tuning problem than God. So it starts to help us make up our mind whether we want to believe in luck or God, right? So if there's many universes, then it's more likely that one of them will be the universe that we find ourselves in, or at least be compatible with the universe as we know it. Okay, and because you can only have 100% total probability, the more likely luck becomes, the less likely God becomes in this possible explanation. Okay, so again, Goff says that when you look at the fine tuning of our universe, and then you conclude that that is the result of multiple universes, that you are committing a fallacy. So I want to now explain why I think Goff is incorrect in his reasoning. So the first one is that conclusions are not conclusions. Conclusions are probabilistic. Okay, so that will take a little bit of unpacking. So it is true that we really should not conclude many players or many universes based on our observation of a lucky streak or our improbable universe. And luckily, that's not what we're doing. Okay? In probability, we are no longer restrained to strict binary logic. It is either true or it is false. It is either A or it is B. Okay, that is not what we are doing with Bayesian reasoning or probabilistic reasoning. Instead, what we are doing is we have a set of hypotheses, and here we have that there are many universes, or there is a God that created the one universe that we have, or that, just for the sake of simplicity, we're saying that those are the only two possible hypotheses. And then we are trying to apportion probability among these competing explanations based on assumptions and based on evidence. And here, evidence is the universe as we know it, and its parameter values. Okay, and so whether we're talking about the roulette example or the universe, okay, and explanations for the fine-tuning problem, one of the hypotheses in either is just simply luck. Okay, and when we only have one possible explanation, then it is certain to be correct. Okay, but again, we're not certain that it's correct, right? Because we're also invoking the possibility that something like a God has created our universe, or maybe some external forces are affecting the roulette wheel. Maybe there's some cheating going on, or maybe God is intervening, or something like that. But as soon as we have more than one hypothesis, the probability has to get split somehow between all of the competing hypotheses. And that's what we're doing here. So we are not taking the evidence and concluding that it is God or that it is luck. Okay? We are using that evidence and trying to see what does that say about the possible explanatory hypotheses between luck and God, or luck and, say, cheating, or something like that in the case of the roulette wheel. Okay? Now, it just so happens that if there are many players or there are many universes, then it increases the probability of it being luck. Okay? That's all that's being said. We are not concluding that it is certainly luck. We are saying that if there were many universes, then luck would be advantaged as an explanation. Okay, so the next problem, or the related problem, is that it's not actually absurd to try to guess how many players that there are in the roulette wheel. So if we had one person and we saw 1 in a trillion run of luck, well then the probability of one person doing that would be 1 in a trillion. And if there was 2 people, it would be roughly 2 in a trillion, not exactly, but something like 2 in a trillion. And we could keep going, and if we had 1 trillion people, it certainly would be more likely that if I had 1 trillion people, or if I saw this evidence of an unlikely streak, it's much more likely that I had 1 trillion people playing than just 1 or 2. And in fact, the maximum number, or the number of people that makes that streak most likely, is infinite people. Okay? And similarly for universes, if I go through the exact same logic, the most probable number of universes there are to produce one that is compatible with the universes we know it is infinite universes, multiple universes. Okay, so now with all of this, there is the role of priors, right? So with the roulette wheel, we don't have infinite players, right? We don't know how many people have played roulette, right? But we would have a prior distribution over all number of people. And so let's say that this is 1 trillion and this is 1 million or something like that. And the distribution might look something like this. So these values would be advantaged in the posterior compared to, less likely values out here and out here. And similarly, I don't know what a prior distribution would be for the number of possible universes, but physicists could come up with and argue about those numbers, but there would be some distribution, and I don't know what it would be. It might be, who knows. But those are going to bear on the posterior distribution. Okay, and now ultimately what we get is that whatever posterior distribution we get for the number of players that are most likely producing that evidence, we can just compare that to the probability of there being a God, okay, or of God being the explanation, and for either the roulette wheel or for the universe as we know it. And all that we're doing with Bayesian probability and reasoning is we are trying to apportion how much of 100% goes to each explanation, whether it's God or whether it is because there are multiple players or multiple universes. Okay, I'm just out of time.